Hi, I'm Charlie Vida. I'm from iRobot. iRobot's been in business for about 20 years, and one of the types of robots that we make are defense and security robots. And these robots are used primarily for reconnaissance, for explosive ordnance disposal. They're used in Iraq and Afghanistan. What they do is they provide a way where soldiers don't have to go in harm's way. They send the robots down to any suspicious devices, improvise explosive devices, and they can safely remove the object or detonate the object from a safe standoff distance. So right here we have the PackBot. The PackBot it was first introduced in 2001, 2002, and it's still in service today. In addition to the military applications, they're also used by public safety professionals, police departments, SWAT teams, and they've also been used in some other types of situations, like after Fukushima, Japan. After the nuclear plant meltdown, 2 PackBots and 2 Warrior robots, a couple of our bigger robots, were sent into the nuclear reactor to detect radiation levels and to assist with cleanup efforts. So that's a general overview of the PackBot. We also have over here, this is called the 110 First Look. So what you see here is a smaller robot, obviously. It's about 5 pounds. And this is one of our newer ones. It's the newest out of our ground vehicles. And like I said, it's 5 pounds. You can throw it, can survive drops of up to 15 feet on the concrete. And its primary use is for reconnaissance. So typically an infantry soldier or a special operations soldier would have this. They could approach a building, throw it up a second-story window, and check out what's inside of the building before sending anybody else in. You know, we're really focused on making robots that are used for a defensive purpose right now. Practical robots. I mean, there'll be a day when other robots are used too. But I think that Hollywood has sort of done a disservice to what and how robots are actually used now. People see movies and they see robot wars. That's not something that we'll see anytime soon.
So we're from Recon Robotics, and this is the Recon Scout Throwbot. Camera is here on the front, IR light in the middle, and then this is the controller, so that you can see what the robot is seeing. So you can throw it up into a building, and then you can see what the robot is seeing up ahead, so that it can identify any obstacles, or we have some pretend IEDs up here, and move it around in a building so that you can see what the robot is seeing without having to stick your head up around the corner.
This is the Skate UAS. It is a small, backpackable, squad-level asset that can be backpackable and weighs 2 pounds. The motor pods pop on and off like this for easy transportation and easy replacement. Fins pop off the back like this, and the entire system comes apart into several components that are then able to be transported in a backpack or a rucksack like this.
Genius.
Yeah, so this is what it is, and you can put it on your backpack or something like that, and full assembly takes about 2 minutes.
I think I saw kind of magic.
Yeah, something like that. Close to magic. Close to magic. But I assure you it works very well. This is a flight vehicle here, and up there is a payload, IR payload, that's downloading video right to that TV and ground station. But yeah, fully autonomous. Right. It can fly waypoints, or you can control it in a manual mode that you can control it with up, down, left, right commands. That goes on. Yep, very easy. Just like that. Yeah.
My name is Steve Morris, president of the MLB company, and we have several products in our booth. Our newest product is the VBAT. It's vertical takeoff and landing aircraft. It is a high-performance wing with a slender fuselage, which is very aerodynamically efficient. And the tail of the airplane has been replaced with a ducted fan lift system, which allows the aircraft to hover so that it can take off vertically, hover, transition to high-speed flight, loiter for up to 10 or 15 hours, depending on how it's configured, and then return to hover for landing. So it's ideal for operating from shipboard operations, also from confined areas like within a forest or between buildings in an urban area. It's a very mechanically simple aircraft. The only moving parts are the control vanes inside the duct. It's very safe because there's no exposed rotors. You could be right next to it when it's running and it will not hurt you. It's also designed to be able to tip over when landing without damage. So these are shock absorbing skids so that the thing could actually fall over and not break. So for landing on ships, we imagine it to come over the deck of a moving ship and just kill the engine and it falls onto the deck and it will not break. The VBAT has greater endurance and speed range than a rotorcraft would have because of its fixed wing design, so it's very efficient. This version weighs 65 pounds. It uses a gasoline engine. It could fly for up to 6 hours with a 5-pound payload, but we have just finished designing a heavy fuel version which can fly up to 15 hours with a 5-pound payload because the new engine is much more efficient. This is the BAT-4 UAV. It is capable of carrying 20 pounds of payload, and it including a gimbal system, and it's good for research work and for anybody who just has to carry a lot of electronic equipment. It can fly up to 12 hours depending on how it's configured, and it gross takeoff weight is about 120 pounds. Uses a runway for takeoff and landing, so it has a landing gear wheel system. It also has an onboard generator, 750 watts of electrical power. And our main product is this aircraft. This is the Super Bat. It is a 34-pound airplane with an 8-foot wingspan. It's launched from a catapult. Catapult is powered by elastic cords. It can fly, launch and land autonomously. So it has a very simple landing gear system because it just lands on these skids. It doesn't have any wheels. It carries a stabilized gimbal camera. It has a protective shield to protect the gimbal during landing, so it's very strong. When it lands, you won't damage this area. It's also very aerodynamically efficient for cruising flight. So this airplane can fly for 10 hours. And it also carries a digital camera in the wing. If you look inside there, you can see there's a digital camera for taking photographs for mapping purposes. And those are the three basic products that we have here. This one, we've flown in winds up to 20 knots. We've demonstrated landings where we reduce the engine power and let it drop to the ground and land without breaking it. We think it's going to be a revolutionary design for unmanned aircraft because it eliminates the need for catapults, runways. So so far we've accumulated several hundred flight hours in flight testing and seen no major problems with the design. It works very well. Oh yes, so our fixed wing airplanes are fully autonomous operation, waypoint navigation, using you click on a map display, moving map display, and the airplane will follow the waypoints. The VBAT is going to be the same way. We are finishing the flight control development at this time. It's not in production yet, but when it is finished, it's fully autonomous. Takeoff, transition, waypoint navigation, landing, all autonomous capability.
So we do wireless power transmission. We take electricity, convert it into light using a laser. We direct that laser beam to a remote receiver, which takes the light and converts it back into electricity. So it is, in a sense, a wireless extension cord. We've gone over long distances, a kilometer, and can go further. and we have done power up to a kilowatt of power out and can go even further. So it's something that can be applied. Here we're talking about unmanned aerial vehicles. It can also be used for remote sensors. It can be used for disaster relief to provide emergency power in case of an earthquake. It can be used for remote things for, say, farmers, for industrial applications. So anywhere that you want to get power where it's going to be too expensive or too difficult to run a power line, the wireless power via laser is a very viable solution. Yes, yeah, it's, we work on custom solutions for any application. In this case, the airplane. So it can be, you can retrofit airplanes with this.
Now, from this on, let me show the standard controls. This would be upper arm up, lower arm up. You move the gripper up, down, sidewise. We've seen the turret in total, turret turn. Now we can turn the lower arm as well. And we finally have a telescope integrated, which you control as well. Package, I just let it fall down. So what you would now have, you show with the camera or with the gripper towards us. Something like that. I open the gripper. And now if we operated in tool center point control, you would have a forward movement, let's say towards this glass or almost towards the glass. So I have to do some corrections, either with a linear movement up, down. Remember, the gripper, the orientation stays in place. We could as well now do a correction such that we look at the glass from the top, and now I go back from the spherical back again to linear movements, which is you either approach the glass, go back, go left, go right, or whatever you call it, up, down now, which would be valid if the gripper would be level. Now the spherical movements again, so the tip of the gripper stays in position. I only tell the system turn the rest of the arm or the hand just around, and same would apply. So this is the standard, the easiest movement right now in this configuration. The next would be another interesting one, the spherical movement, so to say, around the corner. As far as your limiting switches or your mechanical limits would allow. So imagine, try to do this with an old-fashioned type of control. And now then, of course, you would be able to take this glass and move it in a linear movement without the need to stop and do the counterbalancing or do a correction several times. The standard is 3 cameras, forward, rearward, and you see a small one on the gripper. So this is the 3 standard cameras, and then we provide 3 more interfaces where you can add further cameras or other sensors. There is one on top of the gripper. You just go back in base position. So top of the hand you would see one of the extra cameras. Then elbow. This rectangular box is another camera. Standard operation is 1 kilometer line of sight for the digital ones, and for non-line of sight it depends on the environment, so the building or one battery. As you know, see the yellow marker. This box is 1 battery. This is approximately 2 hours. 2 hours. I can control all 4 flippers simultaneously. I can control front pair only, rear pair only, or if I select, I can move each single one. In addition, I have 16. We show another one. This would be for a very stable platform, stowed position. So first the arm would fold, and then the flippers will come up. unfold, you could have a 3D image of the system, and then you just tell the system, yes, move. I'm not controlling certain joints or certain speeds, I just tell the system, move. Yeah? Now it unpacks automatically. The arm is brought forward. And so now we've seen the least or the smallest configuration, and you would now have overhead bin, let's say like in an aircraft.
Right.
You would fully stretch the arm, maximum reach, and now you can still add the flippers. Means the whole system is brought up.
The arm is fully extended and you keep on.
I can still drive, however, drive is at limited speed. You could drive full speed, but you would flip over the system.
Is it automatically that limit your speed or?
No, not. So, bringing it back with the arm still up, you would select any other gripper position and then bring them down. Manipulations in standard. Move the arms or the elements, but that's what we've already seen.
All right, so this is Goodrich, formerly Goodrich, now UTC Aerospace Systems, micro UAV, 3-pound hand-launched UAV, will fly for about an hour, completely modular, 100% open architecture. We can fly multiple different types of payloads. The payload that's in there now, you can see, is a single camera, infrared payload. We have visible spectrum and high definition versions as well. It's a complete system, ground station, airplane, comms links, etc. Really targeted towards law enforcement, first responders, as well as commercial users like precision agriculture.
So we can manipulate this plane by this system.
Absolutely. So it's a user interface. It's 100% touchscreen. It's just like what you would expect on a smartphone or a tablet. You can drag the waypoints around and direct the airplane. It's 100% autonomous. You never have to fly it. So you don't have to know how to fly. You have to know how to operate within your airspace rules. And you just drag the waypoints around and it goes where you tell it to go. It does it completely autonomous. You do need training to do it to make the most out of it, so you can get the most benefit out of it. There is some training, but it's very simple. So you don't need to be a pilot. A lot of the training gets into how do you operate within your rules.
So this is our immersive training system. It's called the Expedition DI training system. And what it does is it puts a soldier into a virtual reality world to train with a squad. In this case, we actually use it for a squad of 9. It has a sensor on the helmet, a sensor on the leg, and there's a sensor on the weapon. We don't have the weapon here right now. And this will allow the soldier to actually move around in the virtual world as if they're in the real world. And it's mainly based for tactical training, and it allows the soldiers to play back what they've done in the training scenario and decipher exactly what they did right, what they did wrong, and use that as a tool as they move forward in the training scenarios that they want to provide. It's very, very a first-person shooter scenario, yes. So when they're in the virtual world, it is a first-person shooter type scenario. But keep in mind that they're wearing the suit, and the suit, when they turn their head, they'll actually look to that side when they're turning their head. If they bring their weapon up, they'll actually see the weapon, and if they have a butt pressed against their shoulder, they'll actually be able to go into a scope mode. So it allows them to be more in a training environment versus a video game environment. And this would come down so the soldier can actually see through the scope. Now, you can't see anything there, but normally you would actually see the virtual world that you're in.
Yes.
And you can actually create any specific demonstration or scenario you'd like to actually create. One on the helmet, one on the leg, and then you have one on your weapon. And it allows you to actually have full movement. If you go to a knee, you go to a knee in the scenario. If you go on the ground, if you lay prone flat on the ground, you lay flat on the ground in this scenario. That is true, and we're actually enhancing the technology to do other things, like additional training for engine training, or for maybe some police force training.
This is a Falcon UAV. My company is veteran-owned. I used to develop UAVs for the Air Force in the United States, and we came up with Falcon UAV because I knew that the public safety communities needed an affordable UAV at the same capabilities as the military has, but at a substantially reduced price because they can't afford military pricing. But they still need the same capabilities of a day-night capable UAV with a gimbaled payload and other payloads. But again, the primary factor, according to them, is affordability with military capabilities. So what we have here is a Falcon, which is a ruggedized professional-grade military UAV. It's all autonomous, GPS waypoint navigation with joystick control if you need it, but again, it's autonomous control, so you're playing more of a Nintendo game than flying the plane. You're not really piloting it. The pilot's on board. It's an autopilot. It does all the work for you. You control a computer and a mouse, and a joystick at a computer and a mouse, and that's what flies the plane. We have one unique feature of the Falcon is that we have a parachute recovery system, so we can land in wooded areas, other type of terrains that you wouldn't be able to land, and even just with the parachute, we do better at not causing damage to the UAV. We don't cause any damage to the aircraft during the landing because it lands on the nose, which is built to withstand the brunt of the force. Ruggedized composite construction, professional grade hardware and components throughout the plane, and again, cost is key. We have pricing on our website at Falcon-UAV, as well as technical information and videos. We're very open with our customers on video, information, data about our platform. We're not trying to be the typical DoD military contractor where they try to suck you in and then catch you at a price tag later on. This plane, this one is currently flying with, or this displayed model has the day-night camera, so it has both Sony block camera with a 10x zoom on it. That's an optical zoom, and then we can carry a thermal infrared FLIR camera with a 640 by 480 resolution. The video range is your limiting factor, and depending on the terrain that you're in, you're going to get up to 3 miles of video. However, we have a GoPro gimbal which records the video on board, so if I wanted to do an out and back mission where I'm just recording, say, a pipeline or pipeline monitoring, I could send it probably 10 miles out and just point the GoPro gimbal down, and then it would be recording video the entire time and come back to me. We added the parachute because it's a concern of law enforcement, which is our initial primary customer. They have a liability concern. They're working with the public, so they need to be concerned about the public's perception of the UAV. So if it has a parachute, that's a safety mechanism that allows them to deploy the parachute at any given time for safety. But we use it as a primary landing method also because, again, it causes less damage. There's less potential for damage to the UAV with the parachute, and we can land in more difficult terrain such as wooded areas, rocky areas, areas where we're constrained from where we can operate from. My background is I was an engineer and officer in the Air Force, United States Air Force. I developed UAVs as part of the Air Force Research Lab, small UAVs in this class, different type of capabilities. However, my background lent itself well to building all types of UAVs. I have a mechanical engineering undergrad and aeronautical master's, and I've been doing technical UAV work since 2005. Our training program is about a week, but I'll tell you, after once you learn to launch the plane, which is a very simple process, as long as you can drive a mouse, you can fly the plane. Again, the autopilot's on board. You have a Google Earth interface that you get to drag waypoints and move the plane around. It's very much more like playing a video game than it is flying a plane. You don't have to be a pilot and have special piloting skills. So again, if you can launch the plane and drive a mouse, you can fly the plane.
This is the Vampire system. It is an embedded training simulation for the Raven, Wasp, and Puma UAS. There are currently about 3,000 of these fielded across the United States DoD, and it is a completely embedded system. So it runs on this Toughbook and on this hardware that is the same hardware used to fly the aircraft. Right. Well, this gives you the ability to train without having to actually fly. So you can do immersive training in any environment at any time, and you don't have to have airspace coordinated. You don't have to have the appropriate weather, so it can be bad weather, and tactical situation or frequency allocation. You can just fly by connecting the system together and choosing your environment. Yeah, that's right, exactly. I think simulation is a very good tool to use specifically for that reason. You're flying something that you're not actually hands-on anyway, so if you can present visuals and an environment with terrain and environmental conditions that are similar to where you're going to fly, then it's almost the same as flying there. Well, I mean, it's a remotely operated vehicle, so the way that you would use it, is there still a requirement for support and other things there? Probably. But those are kinds of questions that we don't really typically deal with at our level. But it's a good training system. Well, we don't actually deal with the actual system, so we don't communicate with a actual remote vehicle. This is a simulation, so there's really no vehicle to be hijacked or hacked, right? So I mean, this is really a closed system from the simulation standpoint. So not a lot of possibility for that with us. No, it's okay. But it is a real world, certainly an issue, yeah.
Well, what you're looking at is a hybrid aircraft simulator that we put together to let people get a feeling for what it's like to fly a hybrid airship. So essentially, a hybrid airship is a vehicle that derives most of its lift from lifting gas like helium, but some of its lift from aerodynamics and some of its lift from its propulsion system. So if you look at the hybrid aircraft from the outside, you can see it looks a little bit like a traditional airship, but kind of squished aerodynamic shape, and it has 4 thrusters on the side that provide propulsive force as well as the directional control for the vehicle. So what we've done with this simulator is we basically put you behind the wheel of a hybrid aircraft and allow you to fly and see how it's the same and how it's different from a traditional aircraft. So you'll notice some things move more slowly than a traditional aircraft. Other things move more quickly. So correct. So the flight controls that are represented here are the same flight controls we'll use in the real vehicle. And so they're fully representative of what the vehicle is using. And the software behind the scenes is a product called Prepare 3D, which Lockheed Martin sells as well, which is a simulation software. And we've taken our vehicle geometry and we've dropped it inside the software and we've connected it to our simulation code so that actually it provides a very realistic experience for the novice pilot.
Educate pilot.
Exactly. To educate the pilot and just to give the interested person, the interested passerby, a feeling of what it's like to fly a vehicle like this, which really isn't an aircraft and it's really not a helicopter, it's somewhere in between.
So what we're going to show today is a hexacopter airframe, which means 6 different rotors. It's a basic multi-rotor. Some of the cool things about this frame is that you can take it apart and put it together by hand because it's got integrated circuitry. So there's no bullet connectors or solder points or anything like that. All the wiring is inside the arm. The ESCs are integrated into the arm as well. So power distribution board is actually built into the mechanical structure of the hub. What that allows is for you to fit this into a very small case to get out onto the field. So let's go ahead and put it together and you'll see how quickly that can be done. It's a simple process of inserting the arm into the bottom, pulling it up, and closing a lever, all done by hand. So with a multi-rotor, of course, your props are either counterclockwise rotation or clockwise rotation. So we just give you a simple X and O symbol on each arm so that you know you're matching up the right rotation. And as you can see, it takes about 15 seconds to put all the 6 arms on once you pull it out of your small travel case. Now there's 6 connection points, 1 for each arm, on the landing skid assembly. So they'll just line up the front of the system with an arrow that's on the top of the GPS antenna. This is our GPS antenna here with an arrow pointing forward. Simply line that up with the camera. And then there's just 6 knobs that they're going to twist 90 degrees to lock it into place. And then once you do that, you plug in the serial port for the camera gimbal and the power. 2 plugs, and you're ready to go. So we'll put our battery on now. We're running 6S 9,000 milliamp power. Gives us about a 10 or 12 minute flight time with this particular configuration. This autopilot system is a GPS-based system, so it has GPS position hold in easily 20 miles an hour of wind. It'll stay right where you want it to stay. It also has altitude from the GPS as well as barometric altitude, so that's very accurate altitude hold. So what we'll do is show you first when they take off just kind of the stability of the airframe in general, and then we're actually going to have a live downlink coming out of that screen right over here on the corner of the booth. So I really encourage you guys to take a look at that during flight, because that's really the special thing that we're showing today. Is this is the world's first gimbal that is perfectly stabilized in 3-axis that can fit onto a machine this size. So that's really probably the most special thing about this unit, is the fact that you can cruise around in 15-mile-an-hour winds and your image is perfectly stable. So no more stabilizing in post, no more trying to follow a subject when the screen is bouncing around. So that's going to be a really neat thing to see, and we're going to be showing that right on that screen. You'll be watching the video feed coming right out of the camera, which will be evidenced by how poor the quality is since there's so much RF in this room. So we're going to show a couple of different modes too on the camera gimbal. We have one mode where the camera follows the aircraft. So if you have to leave visual range, you can go off of your ground control station and know that whatever direction your camera's looking is the front of your aircraft. Then there's another mode. We generally use a 2-person operation, 1 person flying and 1 person controlling the camera. So there's another mode where you can ignore the airframe and your gimbal will stay pointed at your subject no matter what the orientation of the aircraft is. So the neat thing about that is that in a 2-man operation, you're not having to coordinate with the pilot on where you're pointing. So we'll show you those 2 modes. We'll go ahead and take off here. So right now, if you take your hands off the controller, it's just maintaining its attitude based on the inertial measurement unit that's on the aircraft. Now, if we had GPS reception, our 3 red blinking LEDs means that it's not getting GPS reception right now because we're in a big metal building. But when you have GPS reception, it would maintain its position inside of maybe a 4 or 5 foot box, depending on the wind conditions. So let's start taking a look at this camera gimbal. That's really, like I said, the most special thing that we're showing today. Let's show the mode where when you spin the aircraft, it's going to follow the aircraft. So see how the camera is following the aircraft's movement, but it does it with a buffer, so it'll still smooth out that yaw motion. So that's if you need the camera pointing forward. And that's because the autopilot that runs the gimbal and the autopilot that runs the aircraft are communicating with each other. So now let's go ahead and switch the mode into the mode orientation lock so that the camera always stays pointed on a subject. So we'll have Terry focus on me. You'll be able to see me in the screen. And no matter where I walk, he can stay focused on me. Now if you spin the helicopter, you see the camera is staying pointed right at me. We also have, as you can see, all 3 axes have slip rings built in so that there's no issues with video downlink cables being pulled out or power cables being pulled. All 3 axes can spin unlimited. So we're actually taking an HDMI signal out of the camera. We're converting that to NTSC right underneath the camera, on the camera plate. And then we're taking that NTSC signal through all of our slip rings and giving you a simple 12-volt power, ground, and video signal out the top of the gimbal. So you can use whatever kind of video downlink you like. So let's see. Let's go ahead and throw it around a little bit, like you're in a windy condition, and you can see the camera is staying perfectly stable. It's only moving in space. It's not actually changing its pointing at all. So we're stabilizing here to about 200 microradians, which is right around 1 pixel or less than 1 pixel in a 1080p image. The other thing that we'll show you is if you go up a little higher, and Terry, if you look straight down, we can actually do a straight down shot and still control for roll. So if he rolls the helicopter, we have no axis lock because of the mechanical orientation of our gimbal. No matter how Terry spins the gimbal, and no matter how the aircraft is blown around by the wind, you always have a stable image, even when you're looking straight down. So compare that with anything else you'd like to on the market. The other fun fact here is that this entire system is currently available, and everything you see flying, from the GPS-based autopilot system, the fully integrated airframe, the motors, the ESCs, and the sub-pixel stabilized camera gimbal are all available for a total of $6,500. That's retail price. So, and that allows you to pack it up in a small case. Here, Terry, let's point the camera here to this gentleman. Tim, can you rotate around to here? And then move it around a little bit so that you can see the stability of the camera system. Now, if you're using it as a single operation, this ground control unit can actually be used to fly the airframe and control the gimbal. So if you're in a situation where you just need an eye in the sky, you can actually use a tablet computer with Google Earth, simply point where you want it to go, tell it the altitude, it will fly to that location and maintain a hover, or you can fly it to that location manually and maintain a hover, and then switch to a different gimbal on your left hand to control the camera gimbal. So you can actually fly the hexacopter and control the camera gimbal from one controller. So it can be used in either configuration. So anyways, our booth is right over here. It's got a large 80-inch monitor up in the air with a bunch of sample footage playing on it. And we encourage you guys to come by and ask some questions and get some more information. We can shoot you an email with some information on it. And thank you guys for coming over and taking a look today. We really appreciate it. And great flying, guys.
Hi, my name is Charles Easterling. I'm with Crescent Unmanned Systems and Mars Mechatronic Robotics Resource Solutions. We are a system integrator, and we manufacture, it's a consortium of companies that manufacture ground robots, air assets, as well as ground control stations. So we're integrating air assets and ground assets together to perform tasks from a common control platform, and in that common control platform, we're able to utilize our common control controllers to control both air assets and ground assets from a single controller.
I'm Chuck Levin with Max Vision Corporation. Basically, our product centers around portable, rugged computing solutions. We have rack-type systems, a cube system, which is over in the corner there, and then we also have the high-end graphics workstations with 2, 3 displays attached to them. But it's all very rugged and high-end in terms of graphics and computer performance. So.
I saw a booth. I'm not with
Mark Warner, I work for Crystal Group, and we build ruggedized computer systems, networking equipment, and all of our equipment is made out of milled aluminum. It's ruggedized, built to 461, 901, and 810 standards for the military. Our main customers are all military DoD branches, including the Navy, the Army, Air Force, and such. For military, it's what they use. Military uses Windows operating systems. They use Server and Windows 7 quite often, actually.
Oh, really?
Oh, yeah. Yep. I mean, there are certain applications where they need something beyond that. But in general use, a lot of times the server-based operating systems use just a Windows standard operating system. It's very common. Oh. So most of our products are Intel-based, which of course is designed for Windows. And Linux? Oh yeah, Linux works too. Linux, Solaris, anything like that that's Unix-based will work as well.
So what our company does is we manufacture a line of inertial sensors for a number of different applications. This is one example of them. They're notable for their small size, lightweight, and low power. And on this device in particular, we have triaxial accelerometers, gyroscopes, magnetometers, a GPS, and an extended Kalman filter. So it's a small, lightweight, GPS-aided inertial navigation system. And then in addition to this, we have some devices that are strictly AHRS for navigating and controlling unmanned vehicles. And we've recently upgraded all of the gyroscopes on these sensors for very low noise, high precision applications. And the company also does work with miniature wireless sensors for structural health monitoring, for monitoring rotating components, also heavily involved with energy harvesting for powering these wireless sensor networks. The company is based out of Vermont, and check us out. We're online at www.microstrain.com. My background, I went to school in Colorado, studied U.S. government, history, and business. So I am picking up on the technological pieces and enjoying growing this small company in Vermont. And we have a great team, a lot of very intelligent, very dedicated engineers, and looking forward to expanding in this and other markets.
Nihonjin desu ka? So this is a 5 degree of freedom robot. All the joints are clutched, so it prevent any kind of damage. It has a very quick tool change-out mechanism, but it allows various tools to be used. You could use dumb tools like a shovel or a rake, or you could use smart tools that require power and data, because power and data go to the head here, and it goes back on very quickly. Probably the most interesting thing is the control. So this control is shaped just like the robot, and the master is used to, however you move the master, the robot follows. But since I moved the robot, I have to sync the master to the robot. So if you'll allow me, I will do that very quickly here. So once it's synced, then it's ready to go. And all you have to do is move the master, and the robot follows. So that makes using the robot very intuitive, very easy to use, very quick to learn.
日系3世ですけれども、おじいさん、祖父は日本から来たんですね。でも自分は陸軍を除隊してから、3年前に除隊したんですけども、陸軍の特殊戦部隊と空挺部隊にいて、それが除隊してからいつも夜間投資機ですね。夜間投資機のはデプがないんですね。デプというは奥行きがないんですね。デプですから自分が夜間投資機をつけて作戦に行く場合でも、車両を運転する場合でもですね、すごく難しいんですね。で自分はイラクのフルージャの参戦の時に何回も行っています。
その話をちょっと聞きたいですね。
自分は大隊総長だったんですけども、自分の大隊に海兵隊の戦車部隊1個中隊、自分と同じ場所にいまして、その第一車両ですか、防波堤から川の道から見えなくてですね、夜間投資機の奥行きが見えなくて、川に転落して溺死したんですね。でたくさんの兵士が負傷したり戦死したんですけれども、それを直すために作ろうと思って、自分の会社はT3D と言いまして、一つの夜間投資機ですね、から信号ソースのイメージを、コンピューターを通して3次元 3D、3D に見せますね。ですから今までのようにステレオスコーピックは普通カメラを2台で3次元状態にするんですけれども、これは一つのカメラで3次元状態に3D に映して、それからas you see at the eyeglass ですか、メガネはかけなくてもいい整備なんですね。これは DBE と言いまして、例えば戦車とか装甲車とか、それとも消防車とか中につける機械で、機材の後ろの方にはインダストリアルサクションカップにだから窓につけるんですね。それと例えば夜間投資機でも、サーモカメラでも両方でも何でも使えるんですね。That's our system。何のカメラがいいんですね。ソフトウェアとそれからハードウェア。例えばどんなとのハイデフィニッションテレビですね、のスクリーンの上に、レンテキュラーレンズをつけます。だからソフトウェアをするのはリアルタイムにコンバート 2D と 3D にコンバージョンします。
ありがとうございます。
Thank you.
3D になってるってことは分かるのかな、これで。
分かりません。
ちょっと今カメラで分かりにくいですけど、
例えば目で見る場合では、例えばこういう わかりますか？
なるほど。これを実際のオペレーションでは、
はい、使えます。こういうあれをね、カットして入れたんですけども。
なるほどなるほど。ちょっと。なるほど。3D になってますね。当たり前ですけど。
3D でも自分 3D というのはあまり関心ではないんですけれども、っていうのは3D と言いますとみんな何か飛び出すような感じを、ね、受けるんですけれども、自分はこれは要するに運転手、ね、のためですから、車の窓を見るようにセットしないとですね運転できませんから、そういうふうにセットします。でも例えば反対側ですね、何か飛び出るというのもできるんですね。例えばSo, if you see here, 見えますか？
見えます見えます。出てます出てます。
両方できます。はい。それとも例えばですから結局シングルソースイメージをソフトウェアでアルゴリズムで変えて、そしてスクリーンに映すでしょ。だから実際はそれだけですね。だから例えば映画であっても、例えば映画であればDVD をコンピューターに入れればこういうふうに見えます。
素晴らしい。ソフト的にやるといってもリアルタイムでやるためにはやっぱり特別なハードがいるという。
ハードの場合、ハードはスクリーンだけです。
じゃあ 100% ソフトのあれでやってるんですね。
はい、100%。見えますか？
見えます。ちょっとこれだとわからないと思いますけど、僕が今見てて
ね、実際見ればわかるでしょう。はい。だから例えばこれから HDMI とかそういうイメージソースを出してコンピューターに入れると3D に見えます。
なるほど。
このカメラでも。はい。
素晴らしいですね。車の窓でつけてやるっていうさっきのお話がもう感動的に素晴らしいですね。
自分がイラクとかアフガニスタンに参戦した時に部下を何人か亡くしたんですね。だからもちろん戦争で戦死される方は悲しいですけども意味がわかるでしょう。でも事故で亡くなられるとすごく、もっと何かできるはずと思ってだから設計したんですね。それが起源動機ですすいません。
ありがとうございます。あとこれでおしまいでいいんですけれども、昨日もお願いしたようにやっぱり最近のリアルな戦争っていうのはどういうものなのかっていうのはやっぱりちょっといろいろお話を聞いてみたいなっていうのがあるので、
もちろん。
This is Applewhite Aero. My name is Paul Applewhite, and I founded the company. And we have basically two different systems that we're working with for UAVs. The first one's the open source autopilot. It's the Ardu Mega, and we're looking at that for non-military applications. One of them, this particular aircraft right here, we're looking at for something along the lines of, let's say a medical team walks into a village and they suspect this particular person has hepatitis. They can take a blood sample, stick it into this vehicle, and it automatically goes back home. It fits into a small box that we could put into, you know, a Jeep or whatever vehicle that they're in. This vehicle up here, the red one that is kind of built for speed, we're looking at it for something like a target vehicle or a high altitude test vehicle, but also using, you know, the lower cost autopilot. The large aircraft, we're calling this the Jago. and we have a Piccolo autopilot in it, and so some of these UAVs that they have that are based on the Piccolo cost, you know, $150,000 to $200,000. This is in the neighborhood of a $20,000 UAV, and what our business model is that we're going to train you how to fly the Piccolo system, which is a very popular autopilot system, but we would train you how to fly the Piccolo system with a relatively simple aircraft. And if you're familiar with general aviation, this would be something like the Cessna 152 of the UAV world. This aircraft across the aisle over here with system might be in the neighborhood of, you know, $80,000 to $100,000, and some of these other ones are $150,000 to $200,000. Our aircraft's in the neighborhood of 20, and so we're trying to teach you the exact same system on a significantly simpler aircraft and a lower cost aircraft. We also do design services and using SolidWorks, so we do quite a bit of drafting work for other companies in medical products and some of the aircraft interior industry. My background is I'm a graduate of Georgia Institute of Technology, Georgia Tech in Atlanta, Georgia, and I have a degree in aerospace engineering, and I spent 10 years in the aerospace industry as an aircraft engineer, and I've spent 14 years as a professional pilot, and I have a little over 10,000 hours of flying experience. And what I was seeing was that there wasn't a lot of high quality training in the UAV world, so we're going to try to apply the training that I got in flying airliners. We're going to try to apply that to the UAV world. So we're going to try to hopefully be a one-stop shop for training on the Piccolo, because there's quite a few aircraft out there that use that particular system. And if we're successful in that, we're going to switch to some of the other autopilots that are popular. There's the Micropilot and the Wii and the Kestrel, and we'll switch and start using those autopilots and building training systems around that.
Okay, I'm Paul Stoltz, president of Aero Control Incorporated. We make autopilots, flight navigation systems, and we do avionics integration, and we make both ground control software and flight computer hardware. This is an example of our current flight computer. This is an example of our prototype flight computer. And then this is an example of our current ground station. And you can see right now we're just demonstrating the attitude and heading reference system that's in the autopilot, but it also does a full flight management system, command and control system, real-time telemetry, and payload interface. And this is more of a better demonstration of our ground station. This is flying a pre-programmed mission with simulated, but we're really demonstrating the ground station and the user interface. So that's a short story of what our product is. Autopilots and software ground stations, integrated avionics, and validated software. So software that's been developed in an integrated, systematic way where we have requirements and then design, and then we test that the design meets the requirements in an integrated, systematic way, which not everybody does. Matter of fact, most people don't do that. So that's, in a nutshell, what our company does. My background? Yeah, Paul Stoltz again. I have a bachelor's degree in aerospace engineering from the University of Washington in Seattle, and a master's and doctorate in aerospace engineering from Stanford University, specializing in guidance and control systems. And then I have 31 years experience as a professional aerospace engineer. Worked for Boeing, Northrop Grumman, Orbital Sciences Corporation, and then I've been have my own companies for the last 17 years. Okay, so the autopilot, the basic autopilot, its function is to provide stabilization for the airplane. So altitude hold, typically, where we want to hold a constant altitude, we want to hold a constant heading. That's what the autopilot does. So it reads in information from various sensors, rate gyros, accelerometers, magnetometer, and it provides stabilization for the airplane. And then there's an outer loop, a guidance loop, that feeds into the autopilot that provides flight management, and that typically has a GPS feeding in that gives it position and velocity. And then you have a series of waypoints that you can fly. This goes a waypoint 1, waypoint 2, waypoint 3, etc. And that it's a flight plan that the flight management system causes the autopilot to fly by altitude commands and heading commands or roll commands. And so then that's how the airplane flies along a desired path. And then that path can be changed in flight with the ground station if necessary. But it's all about sensors coming in. So GPS data gives you position and velocity. Accelerometers, rate gyros, magnetometers give you attitudes and rates, vehicle attitudes and rates, accelerations, and heading. And so it's all about taking sensor data in, processing it, generating commands to the actuators and the engine to cause the airplane to fly stably and controllably along a desired trajectory.
Inside. Oh. Yes, yes. Thank you very much.
Okay, just to explain, so this product is a Scancopter CQO for close quarter operation. It is dedicated to indoor operation, so mainly for protection, civil protection, and also for homeland security and so on. So it is quite an interesting approach of the UAVs for indoor application. It's lightweight, it's small, it can go through the corridors, hit the wall, and fly with a lot of safety for him and for the others. And it's very convenient for very unsecured area and quite easy to deploy and to operate. So I'm the owner of the company, and a French-based company dedicated to design of micro and mini UAS, and it's one part of our brand product. I'm engineer in airborne system, and so I founded the company 4 years ago after our working for US company and French company.
Instead of having a normal microphone, this is something we call a microflow. We don't measure the pressure exactly, but we measure the particle velocity. We measure the particle velocity in 3 directions independently, which means that if we have the sound, we can get the direction of sound immediately. And it's all in this sensor, which on itself weighs about 17 grams. So it's small enough to fit on a UAV. You can see it up there. We have mounted on a UAV combined with camera. If you look at the screen here, there's a crosshair. And if you make a sound, you clap, for instance, as I will do.
Yeah, so we've been looking at it.
It shows on the screen exactly the direction, and it makes it visible on the screen. So that's an application we do. And it's so small that you can fit it on a small airplane.
Thanks so much.
Yes, you're welcome. Could go to the other side.
Okay, what you're going to see here is the HDL32E. It's a 360-degree LiDAR sensor, which can measure up to 20 times per second, 360-degree LiDAR pictures. So what does that mean? You can see on the screen here, so this is a live image. So this is our exhibition hall, and each of the lasers, this is one of the lasers, rotates around and when it hits an object, it measures the time the laser takes to hit an object and come back again. And you can rotate this, so this is all true XYZ data. You can rotate it in that direction or in that direction. You can zoom out. You can see, basically you can see the whole hole. This is 150 meters from this side to this side. And the laser can go a total range of 100 meters in each direction. Yes. 32, not 10, 32. And they rotate like this around, all the way around. Yes, the laser beam hits an object and the light comes back. And there's a detector. It's a photodiode. It's not a camera, it's a avalanche photodiode, APD, that detects the light, and then it knows from the time it went out to the time it comes back. It takes some time, and then we know how far the distance is. If it goes all the way to here, the time is longer to come back.
Did you say time?
Time, yes.
You know,
so we measure the time, the pulse goes out, and the pulse comes back. We measure the time. So we get about 700,000 data points in 1 second. 700,000 data points in 1 second. So this image, you can see here, the scans per second is about 11. So 11 times in 1 second, we get all the data points each time back. Yeah. No, you cannot see the laser beam. It's a 905 nanometers, so it's invisible. Yes, so this is a small version, and then we also have a larger version, which is this one. This one has 64 lasers, and it's larger. And if you heard about, Google, they have Google, the internet company. They make a car that drives itself. They use this on the top. Each of the car you see on the top, you will see this one spinning. We call it the eyes of Google car. It's the eyes for the Google car. My name is Wolfgang, and I grew up in Germany. I have a PhD in laser spectroscopy. And then I moved to United States about 10 years ago, and I worked for several laser companies, and now I work for Velodyne LiDAR division.
So we have here our few prototypes. This is currently our first one. We made from the plastics and the different composites, and we made some challenges here with the weight and everything. It made out of the 3 pieces. We have a centerpiece and the top and the bottom covers to guide the electronics and the battery tray. But right now we're in here when we're doing that centerpiece from the composite materials, from the honeycomb Kevlar cell. If you can see, it's very rigid, very durable. And we're using the foam in here, which will be injected molded later on to decrease the weight. So right now we're almost 2 times lighter as we was here. We're also playing a little bit with the different propellers. We probably would use a multi-rotor in here, and that thing in there was flying, and you can check it out. It has some crashes, but just because you have impact resistible body shell, it protects the unit from crashing. It protects it from different impacts. And with something like this, it will be pretty much indestructible, just because it's pretty hard to damage something like this composite. And even in case you crash, the foam will absorb most of the damage, so it will just deform the foam, and it will be pretty easy to replace it. It really times more affordable when replacing something like this. At this point we're just playing with the different solutions here, and we try to figure it out. We're expecting our new product being ready within the 6 months. This is when we're expecting. We'll finish with all this prototyping. We still got to do a couple of things. We're working with Unmanned Innovations with our center board, which is an autopilot with the Linux computer inside. So they offer different flexible solutions for different purposes. We're sharing the booth here, so you can see all their demos in there on the booth. But we're expecting something in about 25 to 30 minutes of endurance of the flight time in here, and we're probably talking about 4 to 5 pounds of the weight with the unit itself. So, within the next 6 months, we're expecting the baby coming in.
Oh, yes. Thanks so much.
Thank you for your interest.
My name is Ricardo Mendes from TechEver. We're here presenting the AR4 Light Ray. It's a mini UAV, hand-launched, fully autonomous, and designed for I-STAR operations. So basically for intelligence, reconnaissance, and tracking operations. The AR4 flies for 2 hours. It can be operated by only one person. Okay, it's very easy to assemble and disassemble. And it's being flown right now in several military operations. Completely autonomous. So you have a ground station, or actually several different types of ground stations, bigger ground stations and smaller ground stations. And from the ground station you program where you want it to go, or what do you want it to observe. Okay? And based on that, the AR4 flies there, does what it has to do autonomously. So you don't have to pilot it. Okay? You just have to say what you want the mission to be like. Okay? And you can even reprogram the mission while the AR4 is flying. So it can go there, and you can reprogram whatever you want him to do while he's flying. In real time. Yes. Yes. So it's HD video, and it's transmitted in real time. Okay. So you can get still images, or you can get a real-time video. Okay, of both EO payloads and infrared payloads.
This one is set right now to an 18 mile per hour top speed, again designed to accompany troops on patrol to be able to match running speeds. We can gear it 35 or 40 miles per hour if we wanted to do so. In addition to four-wheel steer, we can also crab steer with this unit. That's cool. Yeah. That's cool. So we can turn in place. Someone this morning wanted us to impounds right now, standing on it. It bounces. If you drive it rather mildly at low speeds, that'll go out for 4 hours. And if you carry extra batteries with you, you can of course extend the range. So it's like a pit stop.
Hi, so my name is Skip Miller. I'm the founder of UAS USA. We have aircraft that we developed. This is a Tempest that was designed for weather research for tornadoes and thunderstorm study at the University of Colorado. And then we have another Tempest that was used in Navy research, dropping very high from a balloon 10.5 miles above the Earth. We have a new model called the Recon, which is, this one's water landable, water capable, so that you can actually, any water body you can land it in. We have it from just an airframe to any level of sophistication, actuators, electric motors, speed controllers, autopilots, launching devices, carry bags. We have a completely integrated system. You'll see it come by me. And it's, so it's very short distance, just lands on its belly.
It's beautiful.
It's very, very simple. Simple solution. So this does not have a camera, but it's what the customer would want, whatever camera they would want, but it has everything else. The payload, everyone has a different need of what the payload might be. My background is, I was formerly trained as an aeronautical engineer, but I never finished school in that, and I've done many entrepreneurial process. I've run a survey company. I built a freestanding brewery. I had a wood products company, manufacturing company, where my customers became Home Depot and Lowe's and big guys like that. And then I've been competing with model aircraft forever. I'm a national and world competitor and a former world champion of the sport. So I have a big background, and I've been competing and traveling the world for 40 years flying model airplanes. So when we did UAS development,
it was almost automatic on how we think and how we develop. But I'm very much serial entrepreneur, starting companies, and in my latest endeavor, I have a Skip Miller Models is my model airplane company, where I import the very finest model aircraft available in the world for competition. And then the offshoot of that is the UAS side, where we take and develop aircraft specifically for the market and for what the needs are of the emerging civil market. So I'm definitely an entrepreneur with this kind of engineering background.
Thanks so much.
Sure.
I really
nice to meet you. Yes, thank you.
Actually, what Silvus Technologies, what we do is we provide MIMO radios. And MIMO will increase your range, throughput, and coverage area over a traditional single antenna system. And Kinetic is actually one of our customers, and we're providing an IP radio for their Talon.
This is UAV factory, and we are making airframe and subsystems for airframe, including catapult and ground control station and a lot of auxiliary equipment. We are a young company, 2.5 years, sold over 70 airframes all over the world.
皆さんこんにちは。一般社団法人日本種業協会の桜井です。今日はこの iPod Touch を使って無人機が簡単に作れる実験を行いたいと思います。ではテロリストの加藤を紹介いたします。
台車型の市販のラジコンがあります。これにみかん箱を乗せ、この中にダイナマイトを入れて作戦を実行したいと思います。そしてこの iPod Touch をみかん箱につけます。そしてこのように台車に固定します。
というわけで皆さんいかがでしたか？このように UGV が簡単に作れる世の中になってるんですよ。